So this is a large coil winding laboratory, and here we see the winding of the coil for the 45T hybrid for Radboud University. From the left to right, the large piece of equipment you see are the winding machine with the coil form covered in plastic at the moment. In the center is one of the piece lengths of conductor on a spool, which will be used to transfer onto the payoff spool, which is the black shelled spool in the back. And as we transfer the conductor from one spool to the other, it goes through a sandblasting process, which device abrades the surface slightly on the conductor, and an ultrasonic cleaner to completely clean the conductor. And it's also inspected full length during that time. And then once the conductor is transferred from the yellow spool into the black spool, then the coil winding can occur. Right now you can see a lot of the prep work to set up the coil form for winding. Glass cloth is added to the mandrel as a ground plane insulation. In the background, transfer of the conductor from one spool to the other is occurring, and the spool has been removed. And at this time, prep work for the lead anchor, the first attachment of the conductor, is made. And as the conductor is wound, you can see it has a white appearance on it. That's actually glass insulation that a machine wraps around the circumference of the conductor. And it's an 18-layer coil with 5 different piece lengths of conductor in it. And at this point you can see another spool of conductor has been brought in and transferred into the other payoff spool. And between, you can see a joint being made. Between the conductor lengths, a complicated joint is built and then wound into place. At the end of each winding layer, a slot is machined into the conductor and a penetration welded to that, so that we can later on connect it to the helium plumbing circuit as we force feed helium through the windings. And so you can see that after one layer is wound, a device is brought in to machine a slot into the conductor and to weld onto do some welding there. And there's a lift again brought in to fabricate the splice joint up high, which has the curvature of the coil built into it. So it's a pre-bent joint. So the inner diameter is 720 millimeters, and the outer diameter is 1.3 meters in diameter, and it's just under 1 meter in length, with about 15,000 pounds in total weight. So you start to see the size of the coil as the windings really start to build up here. And plastic sheeting is just placed over all the glass insulation to keep it clean when it's not being wound. And I believe this is the last piece length of conductor brought in, and the joint being made right now. It is filling up the winding form completely. At the end of the winding, a perforated sheet is wrapped around the outer diameter to kind of contain it as the coil goes through the later processing of heat treatment and epoxy work. So that's the last turn that's been made, and the tail end is being formed and then wound into place, and the outer glass cloth is added to complete the insulation on the outer layers. And finally the steel perf sheet, and it's done.